What do we have to do to make things thrive? Not just survive, but thrive.
Let's go to space.
So hello everybody, thanks for joining us today. My name is Tim Alatorre. I am the COO and Chair of the Board for Orbital Assembly Corporation. And this is our bi-monthly, every 2 weeks, call, Fridays with Tim. And I'm Tim and you're here with me. So today we're not going to go over any announcements or anything new. I can report that over the last 2 weeks, the engineering team has been working really hard, and I get to be part of that engineering team, and it's been a lot of fun. We've made a lot of progress. There's a million problems and little challenges we're working through between now and the time that everybody's enjoying Voyager Station. And it's been a pleasure for the last several years to work with our engineering team. Seems like everything that comes up, there's a multitude, multiple solutions presented, and we're, just having to do cost benefit analysis across the board and figure out what's the best course forward. But it's a joy to work with people who are ready with answers and solutions, and we're working through things one thing at a time. So with that, I'm going to stop sharing my screen here. Just a reminder that this call is recorded and will be available on YouTube in the next day or so. And we will open it up for questions from you. So I'm looking at chat here. If there's a question that you would like to ask, then you can ask it in chat. Otherwise, you can use the little symbol on Zoom to raise your hand, and we will go ahead and I'll give you the floor and you can ask your question live. So we do have one question here from Benny. Benny, thanks for being here today. He's asking, is the spaceport movable to other locations not at Earth? So everything in space is movable. It's just a question of how much delta V you have available to change your orbits. We have been looking not so much at moving stations, but building stations in different orbital planes and orbiting different bodies for different purposes. One of the things that we've been talking about internally is this idea of creating space cities, space communities, where you have not just one station, but a series of stations and other platforms that create an ecosystem and an economy amongst themselves in this orbit. Transferring from one object to another object in the same orbit is relatively straightforward, doesn't require a tremendous amount of delta V. And delta V, just to kind of break that down, is basically how much energy does it take, which translates typically into propellant to move that orbit. So if you imagine a bunch of stations all in the same orbit, it's fairly easy to just bounce between those. When you start changing inclinations, which is the angle that object is orbiting around a planetary body, that starts to take quite a bit more energy. And so we see that, for kind of day-to-day operations and somebody traveling and commuting to work, we see these cities starting to be formed in these various orbits that would allow commerce to occur. And then if you wanted to go to a different orbit, well, that's kind of like hopping on a plane and flying somewhere else. It's going to cost you a little bit more money, a little more propellant, but you can start to then have trade amongst these different cities. Now, if we start looking at stations and these economies around other planetary bodies, let's say the moon or Mars, that's totally feasible. You wouldn't necessarily move a building from, let's say, Detroit to New York, right? It would just be cheaper and easier to build a building from scratch in New York. And so that's how we're approaching it and how we're looking at it, where it would just be a lot easier to build another station. Now, the idea has been floated, and we thought about it, of having stations that are in an orbit which allows them to go between different planetary bodies, right? If you had like a station that was in an orbit, a cycler, if you will, between Mars and Earth, where it's just constantly in a loop, and you could basically hop on this moving building that's constantly going between the two. So that is an option, right? It's just a question of where you build that station and in what orbit. And now, if you were going to build a cycler, what you'd probably do is build it in orbit around Earth, and then you would, use a considerable amount of delta V to then change the orbit of that station into one where it would allow it to have a cycler orbit. You could probably do the same thing around the moon or around the Lagrange point. So there's lots of options there, but that's kind of where our thinking's at. Let me see here. There's another question, and we got a hand raised. Chuck's asking, will there be space hotels? I mean, the big, whoops, sorry, chat scrolling. Big hotel chains, once they see that honeymooners and others book rooms in space, and will OAC be a part of that? Absolutely. We definitely see that the large players in the hotel industry are going to want to get into space tourism, and we're already seeing the starting of that. There's definitely rumors and things that have kind of leaked into the press about different companies exploring that. Of course, in 2001, Space Odyssey, famously Hilton had their hotel there in low Earth orbit. And will OAC be a part of that? Absolutely. If a hotel chain wants to build a hotel, they typically, most hotels don't have like their own construction companies that are part of the hotel chain, right? They would contract with somebody to build that hotel for them. And that's where OAC would come in. We've got, the technology, and we'll have the capabilities to build these hotels for these various, hotel chains, amongst, in addition to other companies as well. There's a lot of capability for different activities in space. And so, hotels are going to be part of that. So with that, we do have Sebastian has a question. You got your hand raised. So why don't you go ahead and unmute, Sebastian? You can ask your question there.
Yes, thank you. And good evening from Austria. I have a question about the food supply in space. Are there any concepts for the food supply in the space? Is there a normal kitchen? Is there anything specific in the kitchen? Is there any possibility to support you in some things like food and beverage planning or concept F&B in space? Is there anything planned like that?
Yeah, that's a great question, and actually one that I get asked quite a bit, because so there's a number of different factors to that. The short answer to your question, Sebastian, is absolutely. Yes. Just to go into more detail on that. So, up until now, like we just had the Inspiration 4 mission with 4 tourists that went in the Dragon capsule and orbited Earth for 3 days, but they're in a microgravity environment. And when you're in a microgravity environment, your food choices are a lot more limited. You can't just have a cup of coffee or, a bowl of soup. It's gonna go all over your cabin, right? Things float away from you. And so you end up with, very limited options, things that can be easily packaged, either solids or, liquids or paste that can be in a tube that you then can just put right in your mouth. Even water is in a bag that you put in your mouth. So in the microgravity environment, your food choices are a lot more limited. Now, as soon as you introduce even a small amount of artificial gravity, now you start to open up a lot more options for what foods can be available. And in a station like Voyager, which is over my shoulder here, you would have, lunar gravity or more, depending on what the final demand is. And you can have a kitchen making regular dishes and meals that you would experience here on Earth. Now, from a marketing and experience standpoint, I think we'll want to be, very creative in the foods that we provide to make it, a real memorable experience. But your options start to become a lot more broader when you have a little bit of microgravity or artificial gravity. Now, looking at our roadmap, which we talked about over the last couple of calls, our first station, the Pioneer class station, will have microgravity and low gravity modes depending on the season, and so the food choices will vary. Now, we're looking at Pioneer being, for tourism, almost exclusively artificial gravity, that environment. Unless somebody really wants to have that microgravity experience, they could have that too, because the station has a microgravity section. But you would have those food options for those tourism customers. Now, as far as getting food to the station, in the short term, we're looking at every launch that comes up would bring the food and supplies that those tourists and those people would need. But looking long term, I was talking at the top of this call about these cities, right? And these communities where you have multiple stations all working in concert together. At that point, when you have enough space, then you can start to grow and produce food on orbit instead of bringing everything up with launch, right? And that's really the end goal here. What we're all really working for is having a self-sustaining economy in space, right, off planet. And so in order for that to happen, the food part has to definitely be a factor, as well as the beverages and everything else that people need for survival. Let's see, just looking down here. Brogan says, NASA has put out a request for commercial space stations to replace ISS. Is OAC planning to submit a proposal? So there's, I'm not sure what articles you've been reading, Brogan, but that window to submit proposals has already passed. It was let's see, last month, I believe. And we did talk about this previously, but OAC did submit a proposal to NASA. Now, what NASA is actually this current iteration of their commercial space station program isn't so much to build space stations. Right now, what NASA's funding is a portion of the development for space stations. And so they've made, I think, $400 million available, and they're going to be investing in, two to 4 or 5 companies just to help to offset their development costs. Now, one of the great things about that also is that NASA would be in a position to help with some of the research and development, contributing information and IP to that endeavor. So OAC did submit our Pioneer class station to NASA. We're going to be building that anyways, but if NASA wants to help support us in that endeavor, we would love to have that support. Either way, NASA has been incredibly supportive for us to date. We've had many conversations with different NASA engineers and people within the organization. Just most recently, we were touring the Marshall Space Flight Center in Huntsville, Alabama. There's a lot of the infrastructure there would help support us in making modules. We've also toured KSC and NASA Ames. We've met with a lot of people in various institutions. So NASA is incredibly supportive already. If they would like to support us monetarily, we won't turn that down. So that's a long answer to your question. Short answer is yes, we replied. Let's see, Aidan, you've got a question if you want to go ahead and unmute.
Hello, yes, my question was about the construction of PSTAR. How far are you along on that? And what is the timeline for the rest of 2021 and all of 2022?
Okay, well, that's a big question there, Aidan. So just first some background, PSTAR, which is our Pioneer class station truss assembly robot, will be the machine that we use to build the truss. It's actually going to build gravity ring, and a PSTAR variant will build the truss that will be used on Pioneer, the first Pioneer station Mark 1. So we've made significant progress on the engineering of that, and that's the last 2 weeks is actually what we've been focusing on is PSTAR. The gravity ring and the truss for the Pioneer class station, I would say the general architecture of the trusses is complete, and we've started detailed engineering. Gravity ring, I'd say, is probably around the 75% completion. We've started the finite element analysis where in the computer we model it and we spin it up and see what happens and all the forces, and we started the detailed engineering of that. And then the truss for Pioneer class station is about the same milestone. PSTAR, we've made significant progress on that, and the general architecture and the configuration is finalized, and we're working on the various mechanisms that assemble all the pieces. If you were able to see some of the video, or if you attended live our D-Star event in Fontana, you'll see that there were a lot of different components and mechanisms that were moving pieces around. In addition, with PSTAR, that also has automated bolt driving mechanisms. So all of those mechanisms is kind of where we're at right now. The time frame for 2021, the first part of 2021, we're going to finish up all of the engineering and secure contracts for some of the long lead items for PSTAR and gravity ring. Long lead items really are the propulsion systems. That's the primary long lead item. But we're also identifying vendors for the solar panels and the thermal rejection systems and the computer systems. And then the actual fabrication of the truss for gravity ring will begin. Our target date is April 1st of 2021. Now, of course, this is all contingent upon funding, and we're actively pursuing that. In fact, we're getting ready here very, very soon. I know we've been saying this for months, but it's like very soon launching our next raise on Net Capital. So if you're interested in investing and being part of this, grand endeavor, just feel free to send us your email. If you haven't already signed up on our website, you can email us at info@orbitalassembly.com and just put in the subject line investment information or something along those lines, and we'll get you into our mailing list. Because as soon as that goes live, we'll send you an update. Actually, we're limited on, we can't really announce anything until all the paperwork's filed with the SEC. So if you're following SEC filings, you'll get the first notification. But if not, as soon as we file, pretty much concurrently with that, we'll be sending out an email blast to everybody, alerting them to that next raise. So that's kind of the big contingent factor on our April 1st deadline. But that's what we're aiming for. And then 2021, we'll be building out and fabricating the truss for Gravity Ring, as well as the major structural components for the PSTAR. And then 2022, we'll be finalizing all the mechanism design or mechanism fabrication for PSTAR. We will run Gravity Ring through the tests of assembly in an offset gravity environment, where in our facility we'll be basically building Gravity Ring horizontally with cables on a track to simulate microgravity, and we'll assemble everything and disassemble it, make sure everything's working correctly. The first part of 2022 also we'll be doing all of the the various testings, vacuum testing for various components. 2023 will be final verification, testing, assembly, integration with the launch platform, the rocket, and then the launch in Q3 of 2023. So that's kind of the Gravity Ring PSTAR timeline. Now, concurrent with that, at the end of 2022, we're also going to be starting work on the first habitation module for the Pioneer class stations. So end of 2022, we should have all of the rigging and the equipment necessary to build our modules up and running. And then 2023, we're starting fabrication of those first habitation modules. So that's the overall time frame there. And then end of 2023, PSTAR will be building Gravity Ring on orbit, and we'll be doing all the testing and validation on orbit, spinning it up, spinning it down, whatever other maneuvers that our customers want, because Gravity Ring will have payloads on it. And then shortly after that, we'll be then preparing to launch the next component, which will make the truss for the Pioneer class station. That'll be happening in early 2024. Okay, let's see here. We've got next question. So I'm not sure if Benny wants me to read this one on the recording, but Benny, if you've got an idea and you're interested in sharing it with us and having a conversation about some product you're developing, feel free to reach out to us at info@orbitalassembly.com. CRIJ74 is asking, what are the plans for PSTAR Mark 1, the prototype Ring 1, after it is assembled, and will it be utilized or just deorbited? Well, that's a great question. And I think maybe if we back up to what Orbital Assembly Corporation's kind of our corporate culture is, and that is, if we're putting something up in space, let's make it count, right? So our stations in general, we're looking at zero waste, and right now NASA has historically had the philosophy of, if you build something, it's okay if you just toss it, right? Or if you get it into space, you can toss it. So that's been their philosophy with rockets on NASA's, the ISS. They're jettisoning all sorts of waste product back to burn up in the atmosphere. We're paying good money to get stuff into space, including the waste product that was produced by people, right? We don't want to just have that burn up. So we are exploring all the different options for PSTAR and Gravity Ring and what we can do with them. In particular, on Gravity Ring, that's an asset we'll have on orbit, and we're going to have paying customers using it. So as long as we can keep business going for that Gravity Ring, it'll be operational, and we'll have people, putting payloads on it. We also were having a conversation this last week about the PSTAR in particular. Even if we didn't use that for anything else, we see that as a very important historical piece of space hardware. And so we're talking about potentially moving that to a parking orbit to where it can be memorialized, or in the future we could reuse it. And also there's just a lot of aluminum there, potentially repurposing that is an option as well at some future point. So, we're looking at everything as, if we put it in space, it's going to be there forever, and we want to use it in a constructive way, and not just deorbit and burn it up. Now that I've said that, that might change tomorrow, so don't hold me to that. But that's our current line of thinking. Then Benny also asks, what will be the waste problem for the toilets? There's really no waste problem with toilets, other than, I mean, if you consider the waste a problem. But again, human waste is a valuable resource. You can repurpose that. You can make repellent out of it. You can recycle the water, extract the various chemical components. I guess one of the big problems with toilets, which is one of the reasons why we've been advocating for artificial gravity for so long, is microgravity toilets are awful. And so having an artificial gravity toilet, even with a small amount of gravity, will make a huge difference. So I guess you could say the waste problem for microgravity or zero gravity toilets is huge, but hopefully toilets on artificial gravity stations will feel much more normal of what you're accustomed to on Earth. Let's see, there's a question from, let's see, Don Matheson. Will the FAA document strangle or destroy SpaceX? Will that then strangle orbital assembly? So those are two very different questions. I'll answer the Orbital Assembly Corporation question first. We are not dependent on any particular launch provider. And that is something that we're working really hard to maintain. As long as there's competition in the launch market, we will be fine. And if there were no launch providers, then I guess we would work to make our own. But no, and I think specific, you're talking about Starship, because obviously SpaceX is launching Falcon 9 just fine. So if Starship were to stop tomorrow and that whole program went away, would we be unable to build Voyager Station? No. Would it potentially set back some of our timelines? Yes, but we are not dependent on SpaceX. As to if the FAA document will strangle or destroy SpaceX, I think that's kind of going back to what I was saying. They've got Falcon 9, they've got other platforms, but SpaceX has already shown that their long-term vision is to launch on offshore platforms, not within U.S. airspace, in which case that regulatory environment changes dramatically, and we'll see what they do. I don't work for SpaceX, so I don't have any inside knowledge on what they are doing, other than what all of you are probably aware of that's made it into the press and what Elon Musk tweets. Let's see. Jonathan Blatter is asking, are you talking about 2022? 2021 is almost over. Oh, you know what, John? I was actually off of my ears. Yes. So everything I said earlier about 2021 is happening in 2022. We're launching in 2023 on for Gravity Ring PSTAR. I can't remember what I said. 2021 wrapping up engineering. 2022 starting fabrication April 1st. Modules are starting fabrication in 2022, launching in 2023 for Gravity Ring PSTAR. So I'm not sure if I messed up my dates earlier, but that's what I meant to say. Let's see. Yeah, and what Tom Spilker, our chief technical officer, he also dropped in the chat just a comment. I kind of glossed over this. Staying in orbit doesn't come free. There is drag in orbit, and you slow down. So it does take propellant to make up that drag. So that's another factor in what we do with Gravity Ring and PSTAR is, if you go high enough, those propellant requirements drop significantly. But that's something that we're considering as well. Aidan, you've got a question, go ahead. And we've got about 5 more minutes. So if you've got a question you want me to address, make sure you drop it in chat. I'll try to get to it today. But Aidan, go ahead and unmute and you can ask your question.
Okay, thank you. I was going to ask, can the Pioneer class station be used as an observatory if like you were to put a telescope on board?
So if it could be used as an observatory, I should preface my response by saying that I am not an astronomer or planetary scientist. So take my response with a grain of salt. My understanding about telescope platforms is they really benefit from being stationary as opposed to being in rotation. But all of our stations have a center portion which it's still rotating. Maybe possibly if the station was not in rotation in microgravity, you could do that. I do know that satellites are orbiting around the Earth and they compensate for that. That's a question I'll have to get back with our team, because we have people on our team who could answer that question probably very quickly and know exactly the solution to that. I would say that right now we're not planning on the stations, one of their uses as being for a platform for observation. But our PSTAR technology and our trust baking technology could easily build a large structure that could be used for an observatory. And I would say a lot less cost than some of the other things that are out there right now. Let's see. A lot of questions came in right now. I'm going to try to get to them all quickly. Let's see here. Albert's asking, would you publish a document on your potential timeline for clarity? So yes, we have a document actually ready to go. When the next net capital raise launches, on that net capital page, we have a timeline of all these milestones I've talked about today. So that'll be there, and you can refer to it and dig in a little more. And I would say, I would expect probably concurrently with that, we'll also put that on our website. Brogan's asking, can you talk a bit more about expectations plans for the 2025 to 2030 timeframe? So 2025 is our goal date and our planned operation date for the Pioneer class station Mark I, and 2026 will be the beginning of the fabrication of Voyager station, with it being operational in 2027. So 2027 will be first spin up an operation of Voyager station, and so from 2027 through 2030, in that time frame, we would finish building out all of the 24 modules in Voyager station. Normal tourism and operations would be ongoing. Other services would be provided. I would expect us to finish Voyager station well before 2030, and so then we would probably begin work. Well, I shouldn't say probably. We would roll right into the next station, which would be Mark II. I would say the one caveat to that would be if there was a significant financial impact globally, and the market for space wasn't as robust as we project and as other people are projecting, then that might slow down the pace of the next station. But right now the numbers are so high, and I mean, just recently, like with the Voyager or the Dragon launch of Inspiration 4, SpaceX is being inundated with requests for people to go to space. So there's a lot of demand. So 2030, I think we're rolling into the next Voyager station. Yeah, Tom Stoker, our CTO, he chimed in here just on the observatory response I gave. He said, most likely not using Pioneer class for an observatory. He said not only rotation, but he also brought up the good point of human habitants aren't good for observatories. We tend to move around and cause vibrations, so that would be a factor. Let's see. Okay, let's see. We got one more question here from Benny. He says, will people have to take a course before going there? I'm guessing maybe you want to provide some clarity on that question, Benny, but I'll just try to guess what I think you were asking. So I'm guessing tourists going to either Pioneer or Voyager station, will they have to take a course? I've talked about this previously as well. The Pioneer class station isn't going to be the same level of luxury as the Voyager class station. And so the people going there, just like the Inspiration 4 crew had to go through a lot of training for their activity, there will be some training to go on a Pioneer class station. You're going to be going, our current plans right now are that you would be arriving in a microgravity environment, the station will spin up, then the station is going to spin down, then you're back in a microgravity environment, getting on your craft and returning. And so there would be some training and orientation for that. Now, when we get to Voyager, that one, you're coming up, whoever's launching you, they will probably have their own requirements for training just to know how to handle that trip. But when you get to Voyager station, you're pretty much in a I wouldn't say a familiar environment, because you're at 1/6 G as opposed to 1G, but the training requirements would be a lot less. You wouldn't have to go through as rigorous a process to go to Voyager. And going back to our big vision, our big goal, we're trying to create a platform and an ecosystem where anybody can go to space, and making space available for everyone. So if you think about the different barriers to entry that would limit people coming into coming to a space station, we're looking at all of those and trying to whittle those down. So that's right now the big one that nobody else is really tackling right now is artificial gravity. And then we talked about food earlier, other accessibility issues, people with disabilities or health concerns that might limit them from, going to space right now, but, we can kind of work around those. And then, training would be another one of those. Financial, I mentioned that as well, bringing costs down, doing things at scale. So yeah, that's definitely one of them. Okay, well, that brings us to the half-hour mark. Thanks everybody so much for joining. Just a reminder that we are going to be starting our next funding round very soon. And if you're not on our waiting list to get notifications about that, make sure you send us an email at info@orbitalassembly.com, and we will send you an email update when that becomes available. And with that, we're gonna stop the recording, and I will see you all back on October 8th, which should be our next Q&A session. And hopefully on October 8th, I will have some exciting announcements for you. We were hoping to have those today, but I think in 2 weeks we definitely will. So thanks everybody, and we'll see you next time.